Assalamualaikum and good day to our respected lecturer, Madam Marjana. Today we will be presenting on multistage centrifugal pump and we are from 3FS. Before that, I would like to introduce my team member. My name is Nur Isati. The second one is Nurul Ain Nabila and the last one is Dina Maisara. Before going into detail, this is the overview of our presentation. We will start with the introduction, followed by the components, operating principle, application, advantage, and disadvantage of a multistage centrifugal. So, let me introduce first. A multistage centrifugal pump is a pump that uses two or more impellers arranged in series to generate high pressure. Each impellers increase the pressure of the fluid step by step as it moves through the pump. This type of pump is widely used because it can efficiently deliver liquid at high pressure, especially for applications that require long-distance transport or high lift pumping. Multistage centrifugal pumps are widely used in many industries because they are able to deliver fluids at high pressure efficiently. First, in the oil and gas industry, multistage centrifugal pumps are used for high pressure injection and fluid transfer. They help to transport oil, gas, and water over long distance and into high pressure system. Next, in the power generation industry, these pumps are commonly used as boiler feed water pump. They supply water to boiler at high pressure to support steam production for electricity generation. In the mining industry, multistage centrifugal pumps are used for high lift dewatering. They remove excess water from deep mining areas to maintain safe and efficient operation. Last but not least, in municipal water supply system, these pumps are used to deliver water to high-rise buildings and through long-distance pipeline. This ensures a continuous water supply with sufficient pressure. Now, I will explain the components of the multistage centrifugal pump based on the label number. For number 1, packing. Packing is used to prevent fluid leakage along the shaft while the pump is operating. For the number 2, bearing. The bearings support the shaft and allow it to rotate smoothly with minimal friction. For the number 3 is bearing housing. The bearing housing holds and protects the bearing in the correct position. For the number 4 is discharge flange. The discharge flange is the outlet where the pump fluid leaves the pump. For the number 5 is closed impeller. The closed impellers rotate to increase the pressure and velocity of the fluid at each stage. Next, for the number 6 is the volute casing. The volute casing collects fluid from the impellers and converts velocity energy into pressure energy. Next, for the number 7 is wear rings. Wear rings reduce leakage between the impeller and casing and protect components from wear. For the number 8 is suction flange. The suction flange is the inlet where the fluid enters the pump. For number 9 is impeller eye. The impeller eye is the central opening of the impeller where fluid first enters. For the number 10 is packing gland. The packing gland compresses the packing to control and reduce leakage. For the number 11 is packing. This packing also helps to seal the shaft and prevent fluid leakage during operation. Lastly is shaft. The shaft transfers power from the motor to rotate all the impellers. So that's all from me. Now let's see how this pump works on the next slide.
I will explain the operational principle of multi-stage centrifugal pumps through this short video.
The suction port directs fluid to the first impeller. One impeller for each stage is attached to the shaft. Each impeller fits into a volute chamber in the casing. A stage is composed of rotating impeller and a stationary volute in the casing chamber. Fluid exits the pump from the discharge port. Fluid enters the first chamber at suction line pressure and leaves the first impeller's outer edge at an elevated pressure. Upon leaving the first stage, the fluid enters the second stage where the pressure is increased further. Each succeeding stage increases the pressure of the fluid. Finally, the fluid exits the last stage and leaves the discharge port of the casing at a pressure much higher than the pump suction pressure. Several other configurations are available. These pumps are used to transfer fluid from a low pressure system to a high pressure system.
Multi-stage centrifugal pumps are widely used in various industries due to their ability to deliver high pressure and maintain a continuous flow. In the food industry, these pumps are used for the pumping and circulation of processed water and chemical solutions during sugar refining, bleaching, and disinfecting operations. In wastewater treatment and chemical industries, multi-stage centrifugal pumps are applied for pumping liquids in water purification processes, deodorization of sewage, and the treatment of industrial effluents where high pressure flow is required. In the agriculture industry, these pumps are used to transfer liquid chemicals during the manufacturing and processing of fertilizers, fungicides, and insecticides. They are also used in textile industry for pumping bleaching agents and processed water involved in the bleaching of fabrics and silks. Additionally, in the pulp and paper industry, multi-stage centrifugal pumps are utilized for high-pressure pumping of chemical during pulp bleaching, fireproofing treatments, and wood preservation processes. Overall, the use of multi-stage centrifugal pumps in these applications is due to their capability to generate high operating heat and provide reliable performance in industrial processes.
Now, let's move on to the advantages. The first advantage is increased pressure. Because a multi-stage pump has several impellers working together, the pressure increases step by step as the liquid moves through each stage. This allows the pump to produce very high pressure, which is not possible with a single-stage pump. This makes it suitable for applications where water or fluids needs to be pumped to a high level or over long distances. The second advantage is efficient use of energy. Multi-stage centrifugal pumps use energy more efficiently when transporting fluids over long distances. Instead of using one large impeller, the pressure is built gradually, which reduces energy loss. This efficiency helps to lower operating costs in the long run. The third advantage is that it saves space. Even though the pump has multiple impellers, it is designed in a compact shape. This means it takes up less space compared to installing several single-stage pumps. Because of this, it is very suitable for areas where installation space is limited. Next, let's discuss the disadvantages of a multi-stage centrifugal pump. The first disadvantage is that it is sensitive to solids. This type of pump is not suitable for fluids that contain solid particles or impurities. The internal gaps inside the pump are very small, so solid particles can easily damage the impellers. This can cause wear and reduce the pump's lifespan. The second disadvantage is higher cost and maintenance. Due to its complex design with many components, the initial cost of multi-stage centrifugal pump is higher than a single-stage pump. In addition, maintenance can be more expensive, which is required skilled technician to ensure the pump operates properly. The final disadvantage is limited use at low flow rates. Multi-stage pumps are designed mainly for high-pressure applications. When operating at low flow rates, their performance is not very efficient. In such cases, a single-stage pump is usually more suitable and cost-effective.